Hello everyone, this is Kalpana working as an assistant professor in SNS College of Technology at Artificial Intelligence and Data Science Department. Today we are going to discuss about graph data structure. Let's begin the session. And today's agenda is we are going to recap the previous session and I'm going to introduce a problem statement to think about it. And we'll start with empathy, define and ideate, and we'll see some real-time applications of the graph ADT and a case study. Let's begin it. The recap, we'll see the recap of the previous session. So in previous session we have discussed about knapsack problem. As we all know, knapsack problem, here knapsack capacity is given. So based on the capacity we have to place the items into the knapsack. Here we need to choose the best item among the items, which means the things given, okay, to increase the value of the knapsack. Okay, either we can include the item, that item is really valuable, it adds value to the knapsack problem, then we are going to include that item. So that is called optimization. Else if that item is not at all going to give any value at all, so we are going to exclude that item from the knapsack. So this is what we have discussed in the last session. So just think of any social media networking, like consider Facebook, Instagram, or LinkedIn. So just take an instance, for example, Facebook. Here, friends are connected, right? Say for example, this X is connected with Y. So there is a relationship between these two people, right? So how can we maintain these relationships, and how can we store the details of the particular person and also the relationship between these person, X and Y, Y with A. So like that, how can we maintain those relationships, and how can we store the details of those persons? Okay, so for this, to storing the relationship as well as the details of a particular person and their relationship, we need a special data type called graph data structure. Okay, so that only we are going to discuss in this session, graph data structure. So just see this image here, friends are connected together. So when I say connected, this friend X is connected with Y, Y is connected with A is connected with S, something like this. So it forms a network, okay, network of people. So when I say network, obviously we can use graph data structure to represent it, okay. So each person we call it as node or vertex. I can say each person as node or vertex, and the connection between them I can say it as links, okay, link or edge. Okay, so these are all the terms we are going to use in graph data structures often. Vertex and the link. Relationship we call it as link, and the person we call it as nodes. And let's begin with the problem statement. Arun Mehta, he's a system architect at a logistic company, but he needs to model a road network, a city road network to analyze the traffic condition, okay, real-time traffic condition, and he needs to have the delivery stops because he's dealing with the logistic company. So the main thing is he needs to design a city road network, and the delivery spots he need to handle, he need to identify and handle it, and also the traffic conditions, real-time traffic condition updates he needs to have. Okay, based on that only he can divert and he can route the things. Okay, so that is the main thing of that is the main task given to Arun Mehta. Okay, so he needs to identify the fastest route, obviously. So based on the traffic condition only, he can identify the fastest route, and the reachable points, reachable stops, which are nothing but the delivery stops, where and all he needs to stop and deliver the products to the department store or whatever maybe. And support changes, that is he needs to adapt to the new destination points and all those things. Okay, so these are all the problems he needs to concentrate on. And next, based on the given scenario, the scenario we have seen before, we have to identify the pain points. So these are all the pain points of the given scenario. So one thing is that to maintaining a location, large number of locations, delivery points is a tedious one, and getting the real-time updates, traffic updates as a challenging one, and then the querying response time, a high query volume, which means rapid response time is rated. A query is asked immediately, you have to respond to it back. So these are all the pain points for the given scenario, logistic scenario. So based on that pain point, we have defined a problem now, that is Meta needs a system which needs to handle the queries efficiently in a fast manner, and then dynamic updates should be there. That is, if any traffic if any traffic congestion occurs, that he needs to be the system should update that immediately so that he can act accordingly. And then the next thing is that the scalability. That is also a major issue. He needs to handle it. And what type of data structure can handle this? So that is the next thing. So these are all the these are all the points he needs to consider while defining the problem definition. So keeping all those in mind, first we have to identify our data structure, which is nothing but the graph data structure. So with the help of the graph data structure, he can able to design a system for the logistic company. So this is the representation of the graph ADT. So here 0, 1, 2, 3, 4. These things we call as vertices, and the line between these vertices, right? It represents the connection. So here we call it as edge of the graph. So edge represents the connection between the vertices, and vertices stores the exact data. Okay, well, for example, if you take social media, it holds the details of the person. So like that I can say, if you are going to have design a routing system, then we are going to have the source and destination points here. So like that. So the main two terminologies for graph is node, vertex, and the connection, edges. Okay, these are all the main thing we concentrate. So it is represented by G is equal to V comma V. Graph is equal to V comma V. V is nothing but the vertex, E is nothing but the edge. We represent it. Here vertices 0, 1, 2, 3, 4 are vertices, and edges I can say 0 to 1 there is a connection, 1 to 2 there is a connection, 1 to 3 there is a connection, 1 to 4 there is a connection, 4 to 3 there is a connection. So we are going to represent that connections like this. Okay. So we'll see the other types of graphs in the next session. Thank you.